Hi guys, here's the ISEB 13 plus physics lesson on speed. Warning, the end of the video has flashing lights. You may find this disturbing, so you have been warned. Okay, let's take a look at this car. Obviously it's moving, therefore it has speed. It's not stationary. What do we need to calculate the car's speed? Well, to calculate speed, you need two quantities. The distance. You also need to know the time, shown here. With these two quantities, we can calculate the speed of an object. The equation we use is speed is equal to distance divided by time. We normally calculate or use the units for speed, meters per second, and the units for distance therefore are meters, and in science the unit for time is seconds. But we can calculate the distance using miles or time in hours, days, years. We can use different units as long as we adjust our units for speed to fit the distance and the time units. This is called a triangle, and some people like to put the equation into a triangle. It helps with rearranging, and we'll have a look at that now. What speed is this woman running at if she runs 400 meters in 80 seconds? So let's try using this equation triangle. D for distance, S for speed, T for time. We want to find the speed, so we just circle the speed here. And we've been given the distance in meters and the time in seconds. So the first thing to do with the triangle is cover up the thing you want to calculate. So we cover up the speed. And that leaves us with distance in meters with the line underneath, which means divide, divided by the time in seconds. So we take the 400 meters and we divide it by 80 seconds. And we get 5 meters per second. Notice the units for speed, meters per second, actually tell you what you've done. Now we're going to look at something slightly more difficult called relative speed. If two cars are moving, the black one at 10 meters a second and the red one in front of it at 15 meters a second, then the red one is moving faster. So the red one is going to pull away and move away from the black car. At what speed do the people in the black car see the red car moving away from them? Yes, the red car is moving at 15 meters a second, but the black car is also moving at 10 meters a second. So we have to look at the difference between these two speeds. And the distance is 5 meters a second. The black car sees the red car traveling at 5 meters a second away from it. Take this green person standing on the pavement or the sidewalk watching the cars go past. At what speed do they see the cars traveling? Well, they see the black car going at 10 meters a second and the red car going at 15 meters a second. So you see, speed is relative to who's watching, from what position, and whether they're moving or stationary, and how fast they're moving. Now let's look at the cars if they're approaching each other from a different direction. So we have the black car still traveling at 10 meters a second and the red at 15. But at what speed does the black car see the red car moving now? Remember, it saw it moving at 5 meters a second when they were going in the same direction. This time they're going in opposite directions. And when we do that, we apply signs to the speeds. So we give the red car a minus sign and the black car a plus sign, just to show that they're going in different directions. We could give them the other sign to each one. So we could give black minus and red plus, but this is how we've done it. In fact, speed, when it's like this, is velocity, which is another lesson. The difference between the cars now, between minus 15 and plus 10, is 25 meters a second. So the black car will now see the red car traveling 5 times faster. Whoa! It'll whiz past the black car, and the people will feel like the red car is going much faster. To them, it's traveling at 25 meters a second. However, to the green person standing on the sidewalk, the red car is still moving at 15 and the black still at 10. Nothing has changed for them. So you see, speed is relative to where you're watching and who's watching. You're unlikely to get a question on that in your 13 plus exam, but it is something you need to be aware of. Let's have a look at some straightforward speed, distance, time calculations. During the first 14 seconds, the average speed of the rocket aeroplane on the runway is 35 meters per second. We've been given the speed. We've also been given the time of 14 seconds. Can you calculate the distance? They've given us the equation here. Well, to calculate the distance, we've got to do speed times time. And the speed is 35 and the time is 14 seconds. So 35 times 14. And that's 490 meters. Let's look at another question on speed. The car travels a distance of 2040 meters in 2 minutes. Use the equation to calculate the speed of the car. Speed is distance divided by time again. So the distance is 2040 and the time is 2 minutes. However, look at the units for speed. It wants the units in seconds. So we must turn the minutes into seconds. 2 times 60 is 120. So we do 2040 divided by 120 and it equals 17 meters a second. That's the speed. Okay guys, that was a little lesson on speed for the 13 plus. Like, share, subscribe. Hey, and don't forget, speed is relative. Let's get to the marks.